we've done a little bit of exploring how changes to a quadratic equation affect the graph. We call these transformations. You did transformations back in, you probably learned them in 5th grade. When you did reflections, translations, rotations, that kind of thing. Dilations you do a lot next year in geometry. So let's look at quadratic transformations. The parent function for all quadratic equations is y equals x squared. Now that's the one that has the vertex at 0, 0. Give me a moment to get a little graph here. Okay, so it would have the vertex at 0, 0, and that would be the root. Remember, when there's only one root, it's also the vertex because it touches the x-axis at one place. So this is the parent function, that the vertex and the root are at 0, 0. So when I make changes to this, what we discovered was that adding or subtracting a number to the end of the equation, that pen is not working, add or subtract a number to the end of the equation, and it moves the vertex up or down. So if we have y equals x squared plus 4, that moves the vertex up 4. And when I say moves it, I'm talking about moves the parent function. All changes to this, to the parent function. And if I were to say minus something, then it would go down that many. But the width stays the same. So then we looked at some where let's see, we put a negative in front. That's what with the official name for it, with transformations, is a reflection. That's when it flips it upside down. So this one would be, this one just upside down. That's why it's a reflection. And then we had, let's see, what else did we do? We did changes in the width. So I have got to get some new pens. When you put a bigger number in front of this, that's called a stretch. It makes it skinnier or narrower, whatever word you want to put. And then when you do a fraction, so this is bigger than 1. This is a fraction between 0 and 1. This is what's called a compression. So what it does is make it wider, or you could say less narrow. I think I've seen it said that way on a question before, but mainly wider. It's like you're sitting on it, you're compressing it and making it wider. Whereas a stretch is like you take the top arrows and you pull them and you make it skinny, you stretch it. So the only one we didn't look at already was the horizontal moves. So if you have in parentheses a minus, that moves it, and I just wrote the wrong thing. You would think left because negative goes left on the graph, but in the parentheses it goes opposite of how you think. So this would move your vertex to the right 4. And then let's say you had a plus inside the parentheses. That's a horizontal move. That would move it to the left 2. So your transformations are, when you add a number to the x squared, positive is up, minus is down. When you put a negative in front of the x squared, it's a reflection, flips it upside down. A bigger number than 1 is a stretch, makes it skinny. A fraction is a compression, makes it wide. In the parentheses, a minus moves it to the right 4. In the parentheses, a plus moves it to the left. Therefore, if you had this, let's pick this one here, number 6. Write all the ways it changes from the parent function. Well, this negative tells me it's a reflection. It goes upside down. This minus 6 in the parentheses tells me that it goes to the right 6. Remember, you would think left, but it's the opposite. And then this minus tells me it goes down 3. So that's how I would answer that question on on the transformations this equation made from the parent function. So we could get a good sketch of it just from the equation. Now, what if I had to write an equation from a graph? Well, it's not upside down, so I'm not going to put a negative. Look where your vertex is. It's right here at -1, 2. So it moved to the left 1, so that's going to be a +1 in parentheses, and it moved up 2. That's going to be a +2. So if we see the graph and where the vertex is, we can write the equation. We couldn't write the stretch or compression, but we'll learn that later. The ones you have today are no stretch, no compression.